Welcome to the Stormsurf Videos Surf Forecast for the week starting Monday, November 23rd. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights to the North Pacific Ocean, we have a storm in the northern Gulf of Alaska producing 45-foot seas aimed east. It is good news for a change. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, a dip in the jet, just like what we have here. Now, this is not even a very impressive trough, but still, it seems to be supporting gale development. What a trough does is helps create a counterclockwise flow aloft in the upper atmosphere and down at the surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, produces winds. If they're strong enough, produce seas. Seas, if they're high enough, turn into swell as they radiate away from the fetch area. And swell, when it hits your beach, of course, produces surf. All right, so we have a little trough here. But really, going back to Japan, we have a consolidated flow with winds about 170 knots pushing off of Japan. The jet sort of splits a little bit here on the dateline, but not too much. Gets its act back together and consolidates in the northern Gulf of Alaska, producing that gale that we see, or that storm up there. Then ridges very hard north up into Canada, and then down the interior U.S. coast from there and inland. All right, so let's put this into motion. That trough continues east into Tuesday and pushing into British Columbia on Wednesday, while back to the west, another trough. Now notice it's pretty much over the Aleutians, but there's energy that can get south of the Aleutians right in here. So maybe support for another gale on Wednesday, pushing in again into the northern Gulf of Alaska, being fed by, what is that, about 150 knot winds, something like that. And then notice the jet kind of tearing apart as we get into Friday. A split pattern. Typically between the split flows, you get high pressure. And there's indications that we could get into a good offshore flow Friday and Saturday. While back to the west, another trough starts evolving off of Kamchatka on Saturday night, pushing over the dateline. Look at this, being fed by 190 knot winds, pushing consolidated off Japan into Sunday. And that trough then again pushing into the northern Gulf of Alaska on Monday night, almost into Tuesday. Fully consolidated flow. Hey, this actually looks pretty good, believe it or not. But do notice that the jet is, for the most part, or the axis of these troughs is up around 50 north, which is a bit further north than usual. We really want to see them come down like to 45 or even 40 north. But that's not the case. Pretty typical of La Nina. The jet gets displaced to the north. High pressure takes over the balance of the North Pacific. So we're thankful to get whatever we can. All right, let's go take a look down at the surface. Here we go. Surface level pressure, surface level winds, and actually things are looking much better here than what you'd expect from looking at the jet stream. I mean, we have the gale or the trough, the storm, whatever you want to call it, with 45, almost 50 knot winds in the northern Gulf of Alaska. Another gale setting up just west of the dateline, but all fetch aimed north up into the Bering Sea, doing nothing for us. Let's put this into motion. As we get into Tuesday, the gale in the Gulf starts fading, 40 knot winds, aimed southeast at mainly the Pacific Northwest, but down even, swell is expected at least to Point Conception. Given the rather north angle, though, it's really doubtful that a whole lot of energy is going to wrap into Southern California. And this is, for the most part, east of the Hawaiian swell window. Another gale develops as we get into Wednesday, 30 to 35 knot winds over a broad area, pushing over just south of the Aleutians, but that kind of fades out. But then another one develops on Thursday night into Friday. Again, 35, 40 knot winds pushing over the north dateline. Most of the energy you see is in the Bering Sea, completely blocked, shadowed by the Aleutian Islands. That's unfortunate. But then as maybe we get into Saturday, that system sort of reorganizes, starts pushing into the Gulf, while yet another system pushes off the Kuril Islands, and pretty strong at that with 50-knot winds, up to 55 knots as we get into Saturday night. This is looking very satisfactory, to say the least. 50-knot winds pushing over the North Dateline region on Sunday, aimed right at the whole U.S. West Coast and Hawaii, decently continuing even into Monday, then starting to moderate, but 30-knot winds even at that point in time, filling a large section of the northwestern Gulf of Alaska, then finally fading out on Tuesday. In all, it looks like a very promising situation. So we're going to take a look down at the surface. We're going back in time to Thursday of last week. A little gale developed, the same deal over the North Dateline region, 18, 19, 20, 22-foot seas. I mean, nothing super impressive on this. Broad area of 20-foot seas. That's good for like 13-second period energy. Swell from this system is starting to hit Northern California. It started this morning. Rather small, rather modest. A lot of local winds not making for a great canvas for the swell to arrive on. Kind of jumbled setup. Anyway, we get into Sunday. The gale that is now in the Gulf of Alaska started developing with 27-foot seas, building to 28-foot midday Sunday, almost 29 feet Sunday night, and by Monday morning, there you go, 42-foot seas, and now currently at 45 feet in the north, we'll call it the northern Gulf of Alaska, pretty far up there. I mean, here's 50 north. We're almost at 54 north. Well, exactly, 54 north, 150 west. Really focused on, we'll say, British Columbia and the Pacific Northwest, but clearly energy down into California and probably even south of there at exposed breaks. Looking forward, that gale is to push into the we'll call it the northeastern Gulf on Tuesday. Still producing seas, but pretty much moving out of the swell window for anywhere south of, we'll say, Point Reyes. Very much north-angled swell. Secondary swell, in fact, let's go back and take a look at this. Yeah, 26, 28-foot seas on Tuesday. Notice a lot of this is pushed like northeast, but still sideband energy expected from this secondary system. Wednesday pushing through the Gulf. We're more interested in what's going to come behind that. And here we go. You notice there's even a little gale on Friday here in the Gulf, so that's just continued barrage of swell, then a stronger system developing Friday over the North Dateline region, falling south of the Aleutians on Saturday morning with, what's that, about 38, 39-foot seas, pushing through the northern Gulf, fading out, and a stronger system on Sunday, so that's, almost 6 days from now, pushing over the North Dateline region with seas to 49 feet, still, again, pretty far to the north, pushing into the northwestern Gulf. I mean, just a good long stretch of long-running energy there, and then pushing northeast, still 20, 22, 24, 26, 28, 30-foot seas even on Tuesday. I mean, this is just a pretty nice setup for longer period, north-angled swell for the U.S. West Coast and good sideband energy into the Hawaiian Islands. So a decent long run of surf looks possible. Next up, let's take a look at winds specifically for the Hawaiian Islands and Northern California. We're not looking, or all of California, we're not looking at wind swell production, but just the general wind state. Strong trades over the Hawaiian Islands today, and a relatively, we'll call it modest, sort of a junky 10, 15 knot steady northwest wind in exposed breaks in Northern California today. As we get into Tuesday, trades continue pretty brisk for the Hawaiian Islands. North winds, a little bit of pocket of light winds along the coast Tuesday morning. So there is a window of opportunity there. Trades still pretty strong into Hawaii. And then Wednesday, the wind machine is supposed to start building in California, 15, 20 knot north winds. When trades start backing off for the Hawaiian Islands. Then we get into Thursday, much stronger winds for all of Central and North California with a much lighter trade regime for the Hawaiian Islands. Then Friday, the good news comes. High pressure starts building over the Great Basin. You get a offshore flow. This is the classic La Nina kind of fall setup. Offshore winds, long period swell, coming from, should be probably medium period swell by then, coming from the north, continuing, or from the northeast, or the swell from the north, winds from the northeast, sorry. Then we get into Saturday. Notice Winds still a little bit like more northeast for the Hawaiian Islands. Light wind regime for the California coast. And even into Sunday, a light wind regime. Trades continue for the Hawaiian Islands. And we go into Monday, more of the same. This is good news. I mean, just a beautiful weather setup for California, and not bad for the Hawaiian Islands either. But no real sign of cold fronts or anything blocking high pressure, just completely locking down the U.S. West Coast. Precipitation potential, we're just looking at California here. The dividing line for the most part is the Oregon-California border. We'll watch this system after system. Yes, this one pushes down to about, what is that? Point Arena, maybe Bodega Bay, vaporizes. The Pacific Northwest and Whistler in that area, British Columbia, getting a good amount of precip, and then high pressure just locking things down solid. Nary a drop of precipitation south of maybe even Washington. Where are we? We're into Monday a week from now, and still nothing. Just high and dry, high pressure in control. We'll take a look at snow for the southwest, northwest U.S. up into British Columbia. This tells the same sort of picture. Right in here is the bullseye. You can see it, but still, even into, Idaho, maybe some snow there. Continuing on, things dry out a little bit. Where are we? We're on Friday. Same, another front. Another one comes in on, Monday. And this goes out 240 hours, but you see not really. Well, there's maybe a hint of precipitation a week from Thursday, if you believe the models, but only like really light precipitation for California, and no snow indicated for higher elevations. Quick look at snow forecast potential. We're just looking at Squaw Valley here. Nothing for the next 10 days. Snow levels, currently we're down about 80, maybe 7,000 feet. But tomorrow going up to, about 10,005, dropping down as we get into the Thanksgiving time frame into the 5,000 foot range. But then once you get into, late on the 26th, snow levels up at about 10,500 feet and more or less holding there until 10 days out. So snowmaking potential for select resorts pretty good up until about the beginning of the 27th, and then too warm. But there is snow on the ground. I think 3 feet fell at Squaw over the last bit, and it's been cold, so they're blowing snow. So, and Squaw is not that high of an elevation. Other resorts probably about in the same shape as Squaw. So, for early season, Thanksgiving, yes, it's potential to get some runs. Nothing great, but something to warm the legs up on. But then the flip side is the ocean will be pretty active too. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and, of course, the El Nino Southern Oscillation. All right, we're going to start looking first off for the Madden Julian Oscillation, the active phase. We've talked about this before. There's two phases, the active phase and the inactive phase. When in the active phase and when the active phase is over the Pacific, again, the MJO travels from west to east on the equator, from west to east. And when in the active phase over the Pacific, the active phase is like a low pressure system. It feeds energy to the jet stream, helps support storm formation, helps when south of California, helps provide precipitation potential into that area of the country. And so it does good things for us. The inactive phase does the exact opposite. It is it's a high pressure pattern. It shuts down precipitation and steals energy from the jet stream. All right, so what are we looking at here? This is the East Pacific here. This is the West Pacific here. Data from the TAO buoy array, a series of buoys strung across the equator using for monitoring El Nino, but we can also use it to monitor the MJO. The arrows are wind speeds and direction. From the east, these are trades, really strong. Notice the length of the arrows. Strong over the East Pacific, the Central Pacific, and we're very interested in the Kelvin wave generation area, the West Pacific. From 170 west, that's just east of the international date line, 5 degrees north and south of the equator, over to 135 east. When the active phase is over this area, and if it's strong enough, it can reverse the trade winds. And if it does that and it lasts long enough, it can take warm water that's in this area, start pushing it east. If you get successive active phases of the MJO, they can create a string of Kelvin waves, that is balls of warm water that travel under the equator, pushing to the east. They erupt off of Ecuador, and that can be the start of El Nino. Now, we don't see that happening at all right now. But what we're really interested in is anomalies, the wind speed and direction difference from normal. We're looking at the arrows here, and we see almost no arrows. So, though these winds are strong from the east, pretty much normal for this time of year. We go over the central Pacific. Yeah, they're a little bit stronger than normal. See the arrows there? Little baby arrows out of the east. A little bit stronger than normal from the east. But then you get in the Kelvin wave generation area, and they're much stronger than normal. This is indicative of the inactive phase of the MJO. Now, we say that, but we all know, based from the previous charts, that the jet stream's doing pretty good, and there is storm activity. So it is not a 100% guarantee that there will or will not be storm production based on the MJO phase. But in general, the active phase of the MJO tends to support storm formation. The inactive phase, not so much. Looking at the forecast for the next week. So what is this chart? This shows you the east and west component of the wind. Is the wind stronger from the east or stronger from the west than normal? The blues and purples are stronger from the east. The reds stronger from the west. Okay, where are we here? This is the whole planet on one chart. 180 is the date line. Okay, the Pacific starts, we'll say, Ecuador is, around 80 west, so somewhere right around here. California is about, on the equator. South of California on the equator is about here. Kelvin wave generation area starts about here, 170 west to 135 east, so about here. So you go right up the chart there, right up the chart there. Past performance in October, you see easterly anomalies, not horribly strong, but then you get into mid-November, easterly anomalies started building, and they're expected to be exceedingly strong and impenetrable for the next week. Again, that is indicative of a strong inactive phase of the MJO. But if you look at the models, it doesn't seem to be having too much of an effect. Probably the biggest effect this is having is pushing the jet stream north and pushing the storm track north. So storms are not getting south close to Hawaii. They're not getting anywhere close to California. There's no expected precipitation, all driven by this east anomaly pattern. All right, digging a little bit deeper into the MJO status, this is outgoing long-wave radiation, fancy words for cloud cover. If you have less cloud cover, you get more sunlight reflectivity off the ocean, you get these yellow shades, and that is indicative of the inactive phase of the MJO. This per the statistic model. So there's South America, Central America, Mexico, Hawaii. Date line, 180 there. Equator, running right through the middle of the chart there. New Guinea there, Australia, you get it. Kelvin wave generation area right around in here. Inactive phase of the MJO appears to be in control, but pretty weak. Getting weaker 5 days out, with maybe a weak active phase following that, but falling apart 2 weeks out from now. That's the statistic model. The dynamic model suggesting pretty much the same thing, but no weak active phase following, just a dead neutral pattern. Digging a little deeper, phase diagrams, a little bit more detailed view of what the active phase is actually doing. So how do you look at this chart? See that circle right there? Assume you're looking down on the North Pole, and the MJO travels around the equator from west to east. So it's around the outer edges of this chart, from the Indian Ocean, over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Heavy dot is where the active phase ends, so we'll say, the East Indian Ocean, roughly. Okay, and the closer the dot is to the circle, the weaker it is. So a very, very weak active phase of the MJO, this per the statistic model, and forecast to move to the West Pacific 2 weeks from now. The dynamic model, the GEFS model, says basically the same thing, but with the active phase staying very weak, making it to the maritime continent, not even as far west as the statistic model suggests. Going out a little further, going out 40 days, all right? This is the upper level model. It shows the areas favorable for precipitation or not favorable. Runs about a week ahead of what goes on down at the surface. So this is and this is probably, we think it's a statistic model. South America there, Central America, there's the equator right there. Date line running roughly there. Kelvin wave generation area over here. So this looks like the inactive phase. The yellows and oranges not favorable for precipitation. Greens favorable for precipitation. So inactive phase pushing out of the Pacific today, with the active phase trying to build over the maritime continent, but very incoherent, limping across the Pacific, pushing into Central America, maybe mid-December. With the inactive phase, it equally as weak, pushing across the Pacific through, about there, we'll say the end of December, and then another very incoherent active phase following that. So the MJO, not strong at all per this model. Then the CFS model here. All right, so this is, again, the whole planet on one chart, date line running right up the middle, Kelvin wave generation area, the important stuff from here to about here. The blues, this is east-west component of the wind again, and here's where we are today. So what are we seeing? Well, we see a lot of heavy blues, strong easterly anomalies, indicative of the inactive phase of the MJO. In fact, this dotted black contour is the inactive phase of the MJO. That was our last active phase up here in late October. Okay, so inactive phase in control, feeding easterly anomalies, and then the inactive phase is supposed to fade out in a couple of days, but you notice easterly anomalies to continue into at least December 20th, probably through the end of December. In fact, there's an active phase forecast developing over the Indian Ocean around Thanksgiving into early December, making zero headway east. You see this dotted contour here, this purple contour, that is the high pressure bias. That is the signature of La Nina. Building from one contour to two contours on this chart. That is the La Nina base state just taking over, completely crushing the active phase of the MJO. And when the inactive phase and the La Nina base state, when La Nina pushes over, when the inactive phase pushes over the La Nina base state, it actually amplifies, creating stronger easterly anomalies. All right, one more model. This is a 3-month CFS model, but instead of the forecast being down at the bottom, the timeline is reversed, and the forecast is up here. All right, date line runs right up the middle. Same deal, whole planet on one chart. So the east or the west side of the Kelvin wave generation is here, and the west side just west of the date line right here. So we're interested right in this area here. Here's our easterly anomalies. Looks as we get into late December, some westerly anomalies. The yellows and oranges are westerly anomalies. We could assume that'll be the active phase of the MJO, and then another inactive phase perhaps with westerly anomalies trying to get into the West Pacific but not making it. Also notice the preponderance of easterly anomalies south of California, even beyond that down into Mexico, and pretty much from, we'll say, Hawaii on east of there. That's typical La Nina base state. That's our guess. Let's overlay the MJO. Okay, here we go. The dotted contour, inactive phase of the MJO. This is our current inactive phase in control, and that's supposed to hold in the Kelvin wave generation area till about December 9th. Then the active phase sets up, you see this solid contour here, into January 16th or so in the 18th in the Kelvin wave generation area. So December looking to be, if there was ever a productive window, this is probably the window that's going to do that, followed by the inactive phase of the MJO from mid-January into about, maybe not quite Valentine's Day. And then theoretically, active phase building after that, we'll see. Don't believe a model out that far, but at least that's the hope. All right, then let's overlay the low-pass filter here. Now, this sort of tells another story. Here is, we're in two contours. The dotted contour here is the high-pressure bias, the La Nina base state over the Kelvin wave generation area, supposedly building by December, we'll say the 11th or 12th to 3 contour lines and maybe even a 4th contour line in February, that suggests that this La Nina is not going to fade out anytime immediately. If anything, it's supposed to be building into February. That doesn't bode well for next summer or maybe even the fall after that, because it'll take quite a bit of time once the global circulation is changed by La Nina and, the wind patterns change. Even if all this were to disappear, it'd probably take 3-4 months after that for the wind patterns to just return to normal. We don't even see that happening. We have no sense yet at all of when La Nina is going to dissipate. Also, the low pressure bias. This is what we want to see in the Pacific, but it's in the Indian Ocean here. And one contour strong. We had seen some early runs of this model with this sort of pushing, nudging west into the West Pacific. We're not even seeing that anymore. It's just rock solid in the Indian Ocean. You know where the surf potential is going to be this summer, in the Indian Ocean, for sure, given this whole setup. All right, let's go into the La Nina analysis. What's going on? This is ocean at depth. West Pacific here, East Pacific here. Data from the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. We're looking at these X's, these stacks of X's. These are the sensors on the anchor lines of the TAO buoys that are strung across the equator, across the entire Pacific. They relay temperature data at depth that gets sent via satellite to a central processing facility in Maryland. They apply a model to it, get a profile of sea surface temperatures across the Pacific. What we see, and this is Celsius, 29 degree isotherm here. This is about where it's been all winter. The 28 degree isotherm, right on the date line, that's where it's been. The 24 degree isotherm, was over about 130, 135. Backtracked the past couple of weeks to about 140 and holding there. What's all this mean? Well, it means easterly winds are taking warm water, pushing it over into the West Pacific, where you end up with a very shallow, not so warm pattern off of Peru and Ecuador. That is the hallmark of La Nina. Colder than normal warm water in the equatorial Pacific there. Warmer than normal water in the far West Pacific. El Nino is the exact opposite. The trades reverse, start taking this warm water, blowing it, pushing it in the form of Kelvin wave, balls of warm water that push under the equator and then erupt off of Ecuador, building a warm slick here, and that's El Nino. Anyway, what we're interested in is anomalies, the differences from normal for this time of year. We see warm water, 2 degrees normal than water here, warmer than normal in the West Pacific, making it to about 160 west. They've been stuck there. No Kelvin wave production. It's just like a steady state pool of warm water and a steady state pool of cold water here in the East Pacific. 3 degrees centigrade, almost 4 degrees below normal. What is that? It's about 5 degrees Fahrenheit. Pretty cold, filling the entire equatorial Pacific. So, again, if temperatures are colder than normal, that doesn't support evaporation. If that doesn't support evaporation, you end up with high pressure dome building there. And where is California? Well, at 120 west right there. And even Hawaii is at 150, so that's roughly over here. So this suggests the water temperature regime suggests that high pressure should be filling the entire eastern Pacific, and that's pretty much what's going on. A different model, just to compare and contrast, basically paints the same picture. Warm water building in the far West Pacific, but not making really any headway to the east. 160 west, this is where it's been for months now. 1, 2, 3, 4, 5, 6, 7 gradients here. 1, 2, 3, 4, 5, 6, 7, 5 degrees below normal. That's even colder than the other model. And cold water making it the whole way to 160 east. That's almost New Guinea. Very cold, solid La Nina pattern indicated subsurface in the ocean. Sea level anomalies is just the height of the ocean. What's that mean? Well, if you have cold water at depth, it contracts, and if that happens, the water above it will sort of divot out a little bit. The JSON-3 satellite, very sensitive, measures the height of the ocean. These are centimeters differences, 10 centimeters below normal. What's that, like? Probably about like that, not very much at all. But that suggests cold water. So here's Peru, Ecuador, Central America. You see sort of right here this finger of cold water just stabbing into, this is the equator, that's the date line there, Hawaiian Islands up there. So cold water doing that sort of thing. Classic La Nina pattern. If you have stronger than normal trades blowing from the east to the west, they would take that cool water and just push it right in there, upwelling, pushing, and then the warm water, positive anomalies, all that's New Guinea there, all in the far, shunted over in the far West Pacific. Here's the warm cold water trend over time. West Pacific here, East Pacific here. Warmer temperatures are the reds and the oranges. You can see it back last December, January. We almost thought we were in like some minimal El Nino state. Warm water, Kelvin wave pushing from west to east, almost making it to Ecuador into April. Then the switch flipped. Easterly trade started nuking. Colder than normal water developed in the East Pacific, pushing to, well, there's the date line. Took a break in July, and now look where we are. Look at that very cold heart in late October, early November, and just locked down. So this is, again, where high pressure would be in control. So Hawaii's at like 158 west, so almost to the date line. There's the date line. Once you get just over the date line, boom, cold water supporting high pressure, driving the jet stream north. That's exactly what we're seeing even today. The storm track displaced well to the north, just shy of the Aleutian Islands, and then being all pushed up into the northern Gulf of Alaska. All right, sea surface temperature anomalies. The differences from normal for this time of year. There's Peru, Chile's down here, Peru, Ecuador, Central America, Mexico. You get the idea. There's Hawaii. The date line, the equator is roughly there. These are not two different streams. It's all a single stream. The images don't quite overlap. But this is the zoomed-in image. You see pockets of very cold water here along the equator being driven by strong easterly winds, just whipping on the equator, driven by high pressure in the Gulf of Alaska. It circulates clockwise here, counterclockwise down here, and the intersection of those two high pressure systems just funnel trades much stronger than normal, causing this upwelling, causing this cooler than normal water, and it just starts feeding itself. The stronger the trades, the stronger the high pressure, the more the upwelling, the colder water, the stronger the high pressure, until at some point it all collapses on its own weight. We don't think we're anywhere near that quite yet. The 7-day trend. So this is just temperature trend for the past 7 days. Blue, 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 blue. That's temperatures getting colder. Why would that be? Well, we're in the inactive phase of the MJO. That supports enhanced trade, so that's what's driving this colder temperature regime right now. Makes sense, and that probably will continue for another week or so. Of course, the one model we saw says at least for the next month, so that only means stronger high pressure, so we'll see. And then, of course, the consolidated backed up view, but clearly the cold water finger just being driven again by high pressure here, circulating clockwise, high pressure here, circulating counterclockwise, driving the trades and the cold water upwelling pattern. Classic La Nina type pattern. Then let's see what the atmosphere thinks about all this. Okay, looking at the ocean, you go strong, raging La Nina pattern. We look at this, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When there's lower than normal pressure in the Pacific, i.e. Tahiti, the index goes negative. So today, minus 7.83, yesterday minus 7. You go, oh, well, what's that? Well, it's just 2 days. This data is quite noisy. You filter it out, 30-day average, positive 6.36. That means higher than normal pressure in the Pacific, but not unusually strong. We go back a month and look and go, well, we're not really any higher than we were a month ago. And we were in the active phase somewhere in here in late October, early November. So not horrible. And then you go, that's still a little bit noisy. So this sort of gives you your MJO phases. And then the 90-day average tells you from a El Nino, La Nina perspective where you're at. It's plus 7.89 today. That's actually not too bad given, I mean, you look at the water temperature thing, you go, wow, we're just off the charts. It's cold. But, you know, where have we been? Well, we've been hovering about 7.5 or 8, maybe a little bit more. And it hasn't changed a whole lot in the past month. So maybe, just maybe, but I'm not really buying it yet, maybe we're not going to get any worse. Well, remember, you looked at that one chart that showed you the strength of the easterly wind anomalies. They were, you know, they've been blowing, but then in the past couple of weeks, it's gotten really strong. The upwelling and east winds have gotten a lot stronger, and we think this is going to start diving somewhere into the 10 to 12 range, and that would be typical La Nina type pattern. In fact, let's go look at the graph. Here we go. All right, so the Southern Oscillation Index, 30-day average, back January 2018, we were pretty warm. Even in January 2019, we were pretty, not warm, I'm sorry. We were in like a La Nina type pattern that we faded out. In fact, 2018 was for sure La Nina. 2019, we started dropping. Notice the down to minus 15. That's an El Nino type pattern. Each of these downward pushes are the active phase of the MJO. But then since about, when was that? Let's say July, August, September, October. From then on, we've been in a steady upward trend. Here's our most recent active phase of the MJO. Today, yeah, what are we? This says 6. Well, I think the other index we looked at said 7, something like that. But still, we're not even as high as we were in the 2018 La Nina. So we'll see where we go. But we still expect we're going to be up in the 13 or 14 range before this is all over. We neglected to look at this when we were looking at the sea surface temperature anomaly, so we'll take a quick look. Nino 1.2 index, this is sea surface temperature anomaly in the Nino 1.2 area, the area just off the Galapagos and Ecuador. Today, minus 1.456 degrees. This is not the official El Nino monitoring region, but you notice temperatures actually there have come up a little bit. The trend has been upward. The official El Nino monitoring region, the Nino 3.4 index, that's from a point south of California on the equator out to about the dateline. Today, minus 1.210. Keep that in our mind, minus 1.2. And kind of steadying off there. When we dipped down to almost 1.65, something like that at one point in early November, late October, kind of risen a little bit since then. Then the official El Nino sea surface temperature anomaly forecast from the CFS model version 2. All right, so back in July we were about normal. These are actual temperatures steadily downward. So this is the middle of October. So the middle of November would be somewhere around here. End of November, right about here. This says minus 1.4, but what we just saw, we're actually up here at about minus 1.2. So this is overstating the depth of the coldness, at least for the moment, a little bit more. So, and suggesting we're not reaching the bottom until mid-January, where we'll be minus 1.9 degrees. So that's interesting. So at one point, this model was saying down to minus 2.5, so it's backed off a little bit. And it seems to be running a little bit cooler than normal, but still, this will be probably a pretty healthy La Nina pattern. And then it suggests, again, I don't believe a model when they're talking 6, 7, 8 months out in July, but not even returning to normal, down about 0.3 of a degree below normal in almost mid-August. So again, no hope for even a return to normal according to this model, and it's probably as good a model as any other there is out there. So there's all the doom and gloom that we've been talking about, things just not looking good from an atmospheric perspective. Then you look at the wave model and weather models and a string of solid storms forecasts for the next week or so. Take it, run with it, make the best of it. We actually got some snow too, but let's talk about waves. I mean, first, a storm right now in the Gulf with 43-foot seas. I think it's going to go up to 45 feet. And then 2 more right behind that. So a strong series of swells possible, very north-directed. Jet stream displaced the north, so that's the whole La Nina thing. It doesn't shut the storm track down completely, but it does generally tend to make the storms weaker. certainly not as broad as normal, and certainly pushes them to the north. So north angled swell forecast for at least the next week, maybe more. That's a good thing. Make the most of it. Wind, probably a bit of an issue for a while, but then high pressure takes over. Santa Ana's in Southern California, offshore flow. This is kind of a typical La Nina thing too. High pressure just locks everything down. You don't get precipitation. You get groomed, longer periods, smaller swells from the north for days on end. Not bad. If you're a big wave guy, maybe not the best situation, but hey, if you can get surf, you take it, make the most of it. In terms of skiing and snow production and snowboarding, not a great setup. No snow in the forecast for at least, 10 days out. Nothing really in California. The deal is you'd have to travel north, but with COVID restrictions and all that, probably not a good idea. Let's be patient. Let's see how things evolve as we get into January. I mean, typically the snow pattern for California is not stellar till you get into January anyway, so we're still quite a ways out from that. So the good news is surf is on the way. That's great. We'll make the best. In fact, there's a small swell hitting right now in Northern California. Nothing huge, head high, something like that. And forecast to just head up from there. So that's it. Anyway, if you enjoyed the video, give us a thumbs up. Sorry we didn't get it going last night. Sometimes life takes over. Unexpected things happen, and that was the case. So we're here tonight anyway. And so if you enjoyed the video, give us a thumbs up. If you have comments, questions, write in the comments section. We'll do our best to answer them. If you haven't subscribed, please subscribe. You'll get a notification via email when we post the video. If not, go to stormsurf.com. That's where all the data you see tonight is available. You can follow along during the week and then check your knowledge with the video at the end of the week. All right. Anyway, thank you for watching. We'll do this again next week. Same time, same channel, surf permitting. And have a great Thanksgiving. All right. Good night.